when we talk about limits, there are properties of limits that we can use to calculate kind of more complex limits, and we're just going to go over some of those right now. So the first, we have 8 different properties I want to talk about. The first is the constant rule. The limit as x approaches c of the value k. Well, this looks pretty simple, and it is pretty simple, but I think for me personally, I have kind of the ability to overthink it. If we have a graph and we have like a value at c here, and this graph is just like here, this point ck, well, what's happening when it goes k? Nothing. So the answer here is just going to be k, always, every time. So likewise, we've got the identity rule here, the limit as x approaches c of x. Well, if we've got the graph here and we've got the point c, and I don't know, we just have something like this. This is just going to be the point c comma c. Well, what's happening there? Just c. So our answer there is just c. And those two, I think, are the ones that are easiest to overthink. And I actually kind of forgot to write something here before I dive into the coefficient rule. I'm going to write that, let's just assume here, and I'll kind of put it in this box, that the limit as x approaches c of f of x, I'm going to call L. And the limit as x approaches c of g of x, I'm going to call M. And that's really just mostly for notation's sake. But here, if we have our coefficient rule, we've got the limit as x approaches c of the quantity b times f of x. Well, we can actually think of that as the limit as x approaches c of b times the limit as x approaches c of f of x. Well, we know the limit as x approaches c of f of x, that's equal to L. And b, this is just going to be our constant rule. So our answer here is going to be b times L. We can also talk about the sum or difference rule. So the limit as x approaches c of f of x plus or minus g of x, we can rewrite that as the limit as x approaches c of f of x plus or minus the limit as x approaches c of g of x. We know the limit of f of x here is L, so this is going to be equal to L plus or minus, and limit of g of x is M. So you can see this is pretty intuitive. It goes pretty easily. So product rule, we can rewrite as the limit as x approaches c of f of x times, and maybe I'll put this in brackets just to make sure it's clear, the limit as x approaches c of g of x, which is just going to become L times M. Pretty simple. Our quotient rule, same situation, the limit as x approaches c of f of x divided by the limit as x approaches c of g of x, which is just going to be L over M. But of course, in this case, M cannot equal 0. Got to make sure that we keep that in there. Power rule, even more fun. Who doesn't love the power rule? We're going to have the limit as x approaches c of f of x, and all of that is being taken to the n power. So this is just going to be equal to L to the n power. Kind of a weird looking L there, but it is an L, I promise. And this one's kind of my favorite here, the composite function rule. Well, we can think of this as f of the limit as x approaches c of g of x, which is just going to be equal to f of, and because g of x is equal to m, we're going to have f of m, that quantity there. All right, so let's go through some of these. Let's take a look at our graphs here. I'm going to have to kind of zoom out for this because I've got a lot on this page, so hopefully you can follow along. Here we've got a graph of f of x and a graph of g of x. And we're asked here to find the limit as x approaches 3 from the right, remember that positive sign means from the right, of f of x plus g of x. So we're going to have this be, and I'm going to write this out long form here, but I'll probably start cutting it shorter here as we go on. We're going to have the limit as x approaches 3 from the right of f of x plus the limit as x approaches 3 from the right of g of x. Well, the limit as x approaches 3 from the right, so here I've got 2, 4, 6, so here's we got 3. The limit as x approaches 3 from the right looks to be about 6. And if I go down to here, g of x, the limit as x approaches 3 from the right looks to be, well, if I can't go here, so I'm going to have to come here, that's 8. 2, 4, 6, 8. I'm going by 2's. So 6 plus 8 is just equal to 14. Easy enough. Let's look here. The limit as x approaches 5 of 3 f of x minus 2 g of x. Now you can think of this as 3 times the limit as x approaches 5 of f of x minus 2 times the limit as x approaches 5 of g of x. I don't know why I put that in double parentheses, but I did. You don't need to do that. So 3 times the limit of f of x approaches 5. So I've got 5, 2, 4, 6. So 5 is about here. Looks like we're about at 2. So this is going to be 3 times 2 minus 2 times my g of x at 5, 2, 4, 5, about 4. So 2 times 4. So that's going to give me 6 minus 8, which is negative 2. All right, let's go down here and see if there's any others that are a little more complicated. Let's do letter G. Letter G down at the bottom here. The limit as x approaches 4 of the square root of g of x. That looks fun. Well, if I go over to my graph here at g of x at 4 looks like it's going to be, g of x at 4 looks like it's going to be 2, 4, about 5. Okay? So this is going to be the limit as, well, and actually I'm going to rewrite this. Yeah, the limit as x approaches 4 of 8 times g of x, and all of that to the 1/2 power. You don't have this in frame here, but there, now you can see it. All of that to the 1/2 power. So this is going to be equal to, well, we already established that the limit as x approaches 4 is 5. So this is going to be equal to 8 times 5 to the 1/2 power, which is equal to 40 to the 1/2 power, which is equal to 2 radical 10. Beautiful. Kind of ran out of room there. But hopefully you kind of get the idea of what these look like. So let's talk, and we can go over more in class if we need to. Let's talk some more about these types of problems. Now, what if we're not given a graph here? All right, we're given just the limit as x approaches c of f of x equals 3. Not c. Yes, c. Excuse me. The limit as x approaches c of g of x equals negative 2, and the limit as x approaches c of h of x equals 4. So we're asked to find the limit as x approaches c of 2 times f of x, plus 3 times h of x over h of x minus g of x. Well, we're basically going to do quite a bit of substitution here. So this is going to be equal to 2 times 3 plus 3 times 4 over 4 minus a negative 2. Now, this is where you can see I've kind of skipped a step here and cut some stuff out, but that's okay. We don't need to write down every single thing. Now, if you were writing this on the AP exam, you would want to write those limits there. But here in this case, if I'm just solving, like if this is a multiple choice problem, I don't need to write all that out. So this is going to be 6 plus 12 over, what, 4 minus 2 plus 2 is 6. We got 18 over 6 is equal to 3. Let's do one more. Throw some of that composite in. That's what I like. All right. Given f of x is equal to x cubed minus x squared plus 4x minus 1, and g of x is equal to negative 2x, find the limit as x approaches 2 of f of g of x. So this is going to be the same as f of the limit as x approaches 2 of g of x, right? This is the same thing here. So the limit as x approaches 2 of g of x, well, g of x, the limit as x approaches 2 of g of x, is going to be equal to negative 2 times 2, which is just equal to negative 4, right? So now we need to find the limit, or now, I'm sorry, now we don't need to find the limit, now we just need to find f of negative 4. So that's going to be negative 4 cubed minus a negative 4 squared plus 4 times negative 4 minus 1. So it's going to give us negative 64 minus 16, oops, minus another 16, excuse me, minus 16 minus 1, which if you add up should be a negative 97. And that's basically it. That's the properties of limits in action. We'll work on this in class and try and get a better grasp of it, but hopefully this made a lot of sense to you.